Hello everyone, welcome to GW Prime. Your where is here. I'm Nivedita Mohanta, your anchor for today's session. Today's session is on next generation solution to improve PNT security capabilities. PNT can be called the invisible utility as more and more companies, consumers, and governments become increasingly reliant on PNT services. PNT is finding use in everything from civil to commercial to military and overall a strong part of global economy drive. A single point of failure can bring the global economy to their knees. Satellite communication is currently undergoing a significant transformation with the new standards for 5G, 6G non-terrestrial network access which is under development. Keeping in view the evolving landscape of satellite navigation and its integration with other space based technologies and the geopolitical situation, countries are looking for solutions to protect their nations' communication, security, and space based assets. Today, with us, we have our guest, Adam Price, VP, PNT, Spirent Communications, Positioning Business Unit. Welcome to our show, Adam.
Yeah, thank you. Thanks for having me. It's a pleasure.
So, tell us about PNTX and the need for next generation PNT simulation system.
Yes, your opening comments were very valid. At Spirent, we're acutely aware of how PNT is now evolving faster than ever, and it penetrates all of our lives in different formats. Whether you are reliant on PNT in the commercial world or a military world, it underpins so much of everything around us today. At Spirent, we have been in the PNT world for over 30 years, and we see this PNT environment becoming more complex, more signals, more use cases. So we've developed a platform called PNTX, which really does embrace that changing environment and need. We want to be able to offer the PNT world the ability to simulate with high levels of realism this complex and feature-rich environment, so that when PNT service providers and equipment providers are putting their products and solutions into the real world that we heavily rely on, they can be assured that as they've tested those solutions and products with Spirent, they are going to give that level of service that is required for us to go about our everyday lives. And when I say everyday lives, I'm talking about things like critical infrastructure, which are heavily dependent on PNT, things like communication networks, finance systems, etc., all vital to continue to operate to the levels they need.
So, what are the existing challenges in PNT systems around the globe?
Yeah, that's a very good question. For a good deal of time, PNT has had challenges, and many of those have been known about, certainly in the military and defense sectors. So I'm talking about things like jamming signals, where signals are launched in an intentional way to block PNT signals, and also things like spoofing signals, where somebody may want to produce an artificial PNT signal to make a system think that it is somewhere that it is not, for example. So that's been thought about a long time in the defense sector. As we start to talk about these other industries, those ones I've just mentioned, the commercial world is now waking up to some of those similar problems. So again, if we think about, let's start with something like a handset, a smartphone, that has to operate now in very dense urban environments to a level that we expect. And in those dense urban environments, there are many signals prevalent which could unintentionally interfere with GNSS. So how on PNT signals? So how do you know that that handset is operating correctly? Well, by testing it in a simulated environment with these degrees of realism, you can design that robustness in to that handset. And there are other ones. So let's talk about areas like civil aviation, where great deal of press today because of geopolitical situations, where the aviation industry is now very concerned about those types of jamming signals, and they have to be resilient to those. It then goes a step further, where we've seen, again, taking the aviation example, where spoofing is starting to appear, making aircraft think that they are in locations that they are not. And this is something the aviation industry is pursuing at great pace to try and overcome. And at Spirent, we're paying a lot of attention and detail to that, about how we can help that industry. So the challenges have been there for a good deal of time. They are certainly now accelerating due to the number of PNT signals, the number of other signals that PNT signals have to operate in. And now we have areas where there is intentional action to try and block, jam, and spoof PNT signals. And we have to protect all of this critical infrastructure around us from those types of events. And again, that's what we are advancing at Spirent, is to help those PNT system providers build that resilience into all of their PNT systems to avoid effects of things like jamming and spoofing. And that's the challenges we want to help our users overcome.
Right. So how can nations develop resilient PNT solutions for mission critical infrastructure?
Yeah. So a bit like what I've said is that many of these critical infrastructure systems are using PNT signals. They may be GNSS signals from satellites. They may be using inertial signals with sensors. They may be using cameras. They may be using LiDAR. So I think PNT providers predominantly are thinking today around, how can I use a complementary set of signals and fuse them together? That is one of the ways that PNT systems are becoming more robust. So not just using one PNT system for your position and location, but use a suite of them, fuse them together in the right way to give you a complementary position and location and timing system. So I think that is one key area. We've also seen great advances in both space-based systems and land-based systems. Space-based systems are now multi-layered, and there is an evolution happening there. So from those space-based systems, we're talking about GNSS type signals predominantly, and they come from medium Earth orbit satellites and geostationary satellites. And they've been working together for a good number of years at very high altitudes, 20,000 kilometers plus, to give us a space-based PNT system. We've now seen the emergence of low Earth orbit satellites coming into the mix, and then they could be sort of 800 kilometers high, much closer to the Earth, much higher densities of constellations that could also start to produce levels of PNT service to us in our everyday life. I think that the way that the LEOs, the MEOs, and the GEOs could all work together could give us new levels of performance in PNT, availability in PNT, and integrity of PNT. And that's a real key mover. The last point I will make about overcoming them, many of the critical infrastructure today is based on time from space. So
Absolutely.
GNSS signals are one of the prime deliverers of universal traceable time. So where you have critical infrastructure that is dependent on time, so I'm thinking around how you control power grids, three-phase delivery of power, finance transactions, communication networks, broadcast TV networks. Having alternatives in PNT for time or backups for time are critical. And we've seen great advancements in of clocks, for example, that hold over when PNT systems may fail and they need a holdover backup mechanism. Clocks are improving at a great pace. But also land-based terrestrial systems are heavily being discussed, certainly in Europe and the US, as a potential, not just an alternative, but a complementary way of delivering PNT to that timing part of the PN and the T.
There's a growing threat of navigation warfare, which majorly relies on GNSS signals, like you mentioned. So, what alternate services should be developed to protect against spoofing and jamming?
Yeah. Yeah. So if we're talking in the context of nav war and in the military domain, I think there's certainly ongoing investment in the way that we can develop things like antenna technology to protect ourselves from jamming. So how antennas can selectively decide direction of reception of jamming signals, because often jamming is coming from is directional. So there's ongoing work in that area, and that certainly provides levels of protection. And we've seen elements of it start to creep into some of the commercial world as well. So antenna technology for jamming protection is key. Some of the, if I talk about GNSS specifically, there are some great GNSS receiver developers out there now that are adding incredible algorithms to their GNSS receivers to interpret jamming signals and mitigate them. And the amount of digital signal processing in real time has really advanced to be able to selectively do that. So if I'm thinking about critical infrastructure and selecting a technology of choice in my PNT system, I'd be looking from a jamming perspective to be looking at those types of PNT system providers and the anti-jam technology that they have got within it. That's one. I think with spoofing, let me just, one other point about jamming as well. So we have seen the satellite providers and system providers also work to provide higher levels of signal power and selective area power to also help mitigate jamming. I just wanted to make that point. When we move to spoofing, again, the receiver developers, in terms of anti-spoof to protect themselves, we've seen them take good note to some of the basic steps that you can put in place to be able to protect yourself against spoofing attacks. They are also being complemented by the satellite providers now starting to implement authentication signals. So signals that may or may not have a level of encryption in them, where the users on the ground can use a key to be able to receive those signals and know that they are authentic signals that are being received. So spoofers in the commercial world, it'd be very difficult for them to be able to produce authenticated, encrypted signals if the key is not known. So some of that stuff we've learned from cyber, some of the stuff that we've learned from the military world has started to come into that commercial world and new signals being offered. I mean, there are other countermeasures, again, that we can learn from our experience in defense. The last point I would say, and where Spirent comes in, is across many of the different industries. So I'm talking about, again, whether it's handset or chipset, or whether we're moving to things like precision survey, again, GIS systems, etc. How do you know that when you're actually in the field using your equipment, that you know that you are getting an accurate performance from your equipment? And that's what we've been pursuing with Spirent and the PNTX platform. Is we want to reach now to more and more industries that are reliant on high precision PNT signals, and guarantee those customers that if the equipment that you are using has gone through a level of test and simulation with Spirent, you can be assured that the signals that you're using in the field have a high probability that they are accurate and reliable. So I think all of that stuff I've said around how the developers can improve their equipment, that has to be complemented by diligent levels of test and simulation in the lab to be able to guarantee in the field that the equipment is satisfactory.
Right. So there is a lot of discussions on developing low Earth orbit PNT.
Yeah.
How is it better than MEO or geostationary orbit?
Yeah, I mean, the LEO situation is a very interesting one, where there's a lot of investment in space, and certainly availability of high bandwidth, low latency communications has driven a lot of that. Without calling out the obvious names, there are some big constellations up there and continuing to be put up there. I think with LEO, there are a number of people that are pursuing explicit PNT systems, and they're looking very promising. And there are the communication LEO providers that are looking to see if PNT service could be a good second order effect from those communication systems. And the work and research into that is ongoing and still at not, I'd say, at an early stage, but there's some good data coming through. I think what we have to think, what we should be thinking of is, how does LEO both offer a potential standalone solution, but also a complementary one? You know, how could LEO work with existing MEO and GEO in a multi-layered approach to be able to provide higher levels of robustness from the signals in space? So I'll give you an example, you know, where LEO is seen to be able to produce, in some cases, higher levels of power. Okay. But it may have some drawbacks to existing MEO. So where the MEO has strengths and weaknesses, and the LEO has strengths and weaknesses, and the GEO, perhaps they can work together to make sure all of their strengths can come together to provide a robust PNT solution. And if I could reference it to what we see with GIS systems, if you think about, if you want to survey areas of rainforest, and you want to have someone on the ground that is doing survey within that, where you can think of ways here that we could now, for the first time, be fusing Earth observation data from LEOs with high quality, high resolution imagery with high precision, high reliability, high integrity position and location data on the ground, all in one big fused system. And I think that would be a great advancement to the PNT world and also the GIS world. Again, if I could think about us in Spirent, you know, we've taken LEO very seriously. We know it is a disruptive technology and can be utilized over time in many different ways. And again, to reach to new market sectors and new market segments, we want to make sure that we can bring LEO simulation into our PNT mix. We want to make sure that we can bring mapping data from the GIS world into our simulation environment as well, and again fuse that all together. So again, we're giving the PNT system providers a level of knowledge, experience, and validation of these new technologies before they're deployed.
So, what are other innovations that are taking place to improve PNT security capabilities in Spirent or in other companies as well?
Yeah, I think there's a few things there, and some of them I may have touched on. So definitely, I mean, it always surprises us how we continue to invest in space. Space is the great delivery system for PNT. So new signals, new constellations are being deployed all the time, whether that's at the LEO, MEO, or GEO level. So more availability, but the sophistication of the signals that are being delivered to Earth are also advancing. So I've talked about on the digital side of the signals, how they can be added in an authenticated way, so to mitigate spoofing attacks. And I think that's a great leap forward. And if the commercial world can start to adopt that, learn from what's been going on in some of those defense sectors, that would be great. I think the types of the actual physical format and the way the signals are modulated and how they can be brought together, there's again huge advancements there. And nation states, because of their because they are now understanding more than ever the criticality of robust PNT, there's heavy investment in their own national PNT systems in space. So having that localized PNT performance or PNT availability and complementing that with what you've got on the ground, again, is a huge step forward. We in the role that we're playing in Spirent, we want to always be ahead of that. So we are, from meeting our customers and our markets, we are aware of the signals that are being deployed before they are deployed. And we allow our customers to simulate that in a controlled way by us providing those signals to their lab environment. So we're helping them through that development phase. Also, I think we're taking about the way that the signals arrive to the user. That mustn't be forgotten about. We all want more data today. We all want more precision. And that is dominated so much from the environments that we operate within. So whilst the system developers on the ground and the system developers in space are producing more feature-rich, more capable PNT signals, we are trying to help users get educated faster in how those signals arrive to them and how they can be utilized on the ground in the environments that they are operating within. So again, if we want to help people improve availability in urban environments, we can bring an urban environment into our simulation environment. If it's a forest, we can do it in the forest. So this realism bit of the way that PNT signals are simulated is vital, because what that's doing, it's feeding into the developers what is needed. And the developers in turn are feeding that into their systems, whether that's on the ground or in space, so that those signals can then be deployed and be more useful to everyone, from commercial users, critical infrastructure, and then into defense.
So my last question is, how can commercial space help bridge the GPS vulnerability gap by providing alternative PNT services?
Yeah, that's a good question. So I mentioned about the dedicated LEO providers, and we're starting to see a good emergence of those. So commercial space does include LEO PNT, and commercial space includes other things like communication networks, etc. So there's a lot of experimentation going on with low Earth orbit for, like I said, using dedicated PNT signals, but also working with the MEOs and LEOs above them to complement what is being provided already. So I think that's one interesting factor. I think we mustn't forget as well that these large constellations are, as I've said, high bandwidth, low latency constellations. And the way that data can be shared in space now and delivered across vast areas at low latency is something that's going to be very interesting to the data side of PNT. So how information can be shared across a big network quickly so that you can learn about the signals you're deploying and maybe having feedback from the ground into this network in space could be really interesting. And certainly, we're existing where alternative time is being delivered by commercial space today. What we want to see now is how that evolves to start to deliver more and more precise and robust PNT signals from space, from a complementary use of new PNT signals from LEOs, working with MEOs and GEOs, and having this communication network up there that can share all of this information as well. I think it's going to be a really interesting and exciting time over the coming years to see how that evolves.
Thank you so much, Adam. It was amazing talking to you, and I'm sure the audience had a great time listening to you, understanding the challenges of PNT and everything related to the trends and innovations that are taking place in this sphere. Thank you for your time.
Well, thank you for your time. It was very enjoyable. Thank you.
Hello everyone, I am Ekta Barenwal and welcome to another episode of GW Case Study Chronicles on GW Prime. In this special segment, powered by the Geospatial Resource Platform, we delve into real-life projects that exemplify the transformative impact of geospatial and another emerging technologies across diverse economic sectors. These case studies are meticulously curated by GW Consulting and are readily accessible on the Geospatial Resource Platform, providing invaluable insights into groundbreaking innovations driving sustainable development worldwide. Today's episode spotlights geospatial optimization through ME120 USVs in the South China Sea. In this episode, we are delving into an innovative project that showcases the synergy between geospatial technology and environmental monitoring. This project features the use of unmanned surface vessels in the South China Sea, specifically Wanshan Island. This initiative is part of the Rapid Networking Observation Project of Air-Sea Interface Parameters. Ocean Alpha, the project owner, uses Amir 120 USVs that are at the forefront of modern oceanographic surveys. Equipped with cutting edge navigation systems and sensors, these vessels collect critical data on ocean conductivity, temperature, and depth. The primary goal is to enhance the understanding of marine environments and to provide valuable insights for scientific research, environmental conservation, and the maritime industry. Deploying USVs in such dynamic and often harsh marine environments presents significant challenges. Ensuring the reliability and accuracy of data collected, maintaining the operational efficiency of the vessels, and integrating the data into broader geospatial frameworks are a few of the key hurdles that Ocean Alpha has addressed through rigorous technological innovation and strategic planning. The ME120 USVs utilized in this project represent a leap forward in automation maritime technology. These their advanced sensors and navigation systems allow for precise data collection even in challenging conditions. Additionally, these vessels can operate independently, reducing the need for manned missions and thus minimizing human risk and operational costs. The use of USVs in oceanographic surveys offers numerous benefits. They provide high resolution, real time data essential for environmental monitoring and scientific research. This data aids in understanding climate change impacts, monitoring marine ecosystems, and supporting sustainable maritime activities. The autonomous nature of USVs also ensures continuous data collection over extended periods, enhancing the overall quality and reliability of the information gathered. From a financial perspective, the implementation of USVs like the ME120 leads to significant cost savings. The reduction in manned missions lowers operational expenses, while the high quality data collected supports more informed decision making in environmental management and maritime operations, potentially leading to further economic benefits. To conclude, the deployment of ME-120 USVs by Ocean Alpha in the South China Sea exemplifies the transformative potential of geospatial technology in marine research and environmental conservation. By harnessing the power of autonomous vessels, we can achieve more efficient, accurate, and safer oceanographic surveys, paving the way for a sustainable future. For more detailed information on this project, please visit the Geospatial Resource Platform at the Geospatial World website. Thank you for joining us today. We will be back with another interesting case study in next episode.
Hello and welcome to the GW Bulletin, the daily dose of geospatial news on GW Prime Live. I am Jeffy Jacob and here are the latest happenings. Google is set to finalize a $23 billion deal to acquire Wiz, a cybersecurity startup specializing in cloud security. This acquisition marks Google's largest purchase in the cybersecurity space and surpasses Google's previous high of $12.5 billion for Motorola Mobility in 2012. Google is pressing forward with negotiations, and the regulatory bodies may attempt to impede the deal. The US military plans to award an estimated $3 billion multi-year contract for commercial data and analytics services to monitor potential threats across the Indo-Pacific region, a focal point of global geopolitics and a priority theater for the Department of Defense. The program, known as Long Range Enterprise Intelligence, Surveillance and Reconnaissance Activity, seeks to procure a wide spectrum of commercial data and advanced AI-driven analytics integrating information from ground, aerial, and space-based platforms. The Ministry of Rural Development has sanctioned 78 roads and 14 bridges for Assam state in India under the Pradhan Mantri Gram Sadak Yojana. The estimated investment for this project is rupees 378 crores aimed at improving rural connectivity and infrastructure. This initiative aims to significantly improve rural connectivity in the state, facilitating easier access to essential services such as healthcare, education, and markets. By bridging the gap between remote villages and urban centers, these infrastructure developments are expected to enhance overall accessibility and quality of life for the residents of the state. The Union Minister of Ports, Shipping and Waterways, Sri Sarbanada Sonawal, received the first mothership MV San Fernando, marking the beginning of operation at India's first deep water container transshipment port in Vizhinjam, Kerala. The ship, with a capacity up to 9,000 TEUs, docks at India's first automated port, which is equipped with the state of the art that offers large scale automation for quick turnaround of vessels, including capacity to handle megamax container ships. The Chief Minister of Kerala, Sri Pinarayi Vijayan, was also present in the occasion. Union Minister Dr. Jitendra Singh held a meeting to review the Indo-Norway collaboration on blue economy with Norwegian Ambassador to India, Ms. May Ellen Stenner, in the North Block, Delhi. He called upon strengthening the task force that is co-chaired by the Secretary, Ministry of Earth Sciences, Government of India. The minister also recalled the India Norway Integrated Ocean Management and Research Initiative and stated that there is a need to deepen this collaboration. He also shared with the ambassador that India is carrying out deep sea mission by sending 3 Indians to deep sea, which will open a horizon of opportunities in mineral exploration and seabed mining. MITI Labs, a tech-enabled project developer, has launched 5 RISE projects across India aimed at reducing methane emissions and increasing water security, as well as building farmer resilience. MITI Labs is working alongside the Syngenta Foundation, Ebro Foods, and Dr. Reddy's Foundation for this. MITI Labs' first 5 projects will cover 30,000 hectares and will deliver an annual reduction of 120,000 tons of CO2 emissions. The emissions reduction will generate high quality credits that help to diversify credit buyers' portfolios, as well as making a significant positive impact on water scarcity and farmer livelihoods within the region. International e-scooter operator Neuron Mobility is fitting its vehicles with front-facing artificial intelligence-powered cameras. The technology will be fitted to its 1,250-strong Melbourne fleet over the coming months. The move reportedly makes Neuron the first rental e-scooter operator worldwide to introduce the technology on such a large scale in a major international city. The e-scooters are equipped with front-facing cameras that use advanced computer vision technology housed in the e-scooter's IoT box to detect footpath riding, which is prohibited in the city of Melbourne. The system can detect whether an e-scooter is on the footpath in less than 1 second. Dutch solar car company Squad Mobility has been granted 1.35 million euros as part of a 12 million euro tender won by the Giants Consortium. Giants is a 12 million euro consortium funded Horizon Europe project that aims to provide affordable and accessible mobility solutions to both emerging and advanced markets. The company has created the Squad, a compact and affordable solar car that charges itself on direct solar energy through an integrated solar panel on the roof. And with that, we come to the end of this live bulletin. See you tomorrow with more news from the geospatial ecosystem around the world. Thank you.